Hello viewers and welcome to a new STM32 World tutorial video. In this video we are going to continue diving into more details regarding the CAN peripheral in the STM32 MCUs. Now, in an earlier video we covered how to use the CAN with a loopback. If you haven't watched that yet, you should probably go back and watch that first. It will be linked down below, but I made a few shortcuts in that video. So in this video we are going to dive into much more detail about the filtering, and we are going to actually use a CAN transceiver to speak to a proper CAN bus. Now, before I go any further, let me just show you. I created an STM32 World CAN transceiver peripheral transceiver board, and that is the one I'll be using. This one have two CAN transceivers, and what I'm doing in this video, I simply loop a wire between these two, and I'll have a CAN bus, a real CAN bus. So what I will be doing in this video later, I'll do a server, so to speak, on CAN 1 that listen to requests, and CAN 2 will act as a client, so it will request data from CAN 1 and CAN 1 will reply with the data as relevant. Now, in the last video I showed this basic filter that you can see here, where I am using an ID and an ID mask. So I basically have an ID here and a mask which bits are relevant for the matching. And then in this example I actually have three CAN IDs where one of them is not matching the filter, and that means that when we are sending CAN ID 3, it will not be received. So let's try to test that. Yeah. So it should send 5 seconds, then it should send 2, and I only receive 1 back. And then 5 seconds more, it will send 1, and I receive that back. So one of the ones sent up here was actually the one that doesn't match. Now, what we're doing is we are matching on these with a mask and an ID. But there is actually another way of doing this, and that is, I will talk a bit more about that here. So if we comment that out, I have here created the alternative. In the alternative, you can actually, you see this one was an ID mask, this one is an ID list. So you can have a list of IDs in these filters. So each filter have the filter ID low, filter ID high, and filter mask low, and filter mask high. In ID list mode, these are all IDs, even the mask. There is no mask. You will also notice in the last one that I'm shifting these. I briefly mentioned in the last video why I'm doing that, but I didn't really go into detail, mostly because at the time I didn't really understand it. So let me actually explain what is going on here. In the reference manual under the CAN section, you will find this graph or this schematic, and that actually explains it very, very well. So these masks can be configured in 16-bit modes or 32-bit modes. Since we are just using standard IDs, which are 11-bit, we don't need the 32-bit modes. But in the 32-bit mode, you have two options. You can either do an ID and a mask, and then you can match, each filter can match one ID and mask. You can also do an identifier list, where you can then put 2 in. Now, if you look at the mapping down here, that is the important bit. You can see which bits are mapped where in these registers if you run it in that mode. Let's ignore that for now, because we are using 16-bit filters, and in 16-bit filters you're actually not using the top part at all. Or the bottom part, depending on how you look at it. So basically, we have an ID and a mask and an ID and a mask. Oh yeah, we are. Of course, they're just flipped down in two. So yeah, we have an ID and a mask and an ID and a mask. So one filter can match two different IDs with masks, or you can use identifier list, in which case you have 1, 2, 3, 1, 2, 3, 4 IDs that are actually matched. Now down here you can see why we need to shift it 5, because the standard ID starts at the first bit in this register, and then you leave the button empty. We will also see that when you are using this, you actually have the type of package, whether it's a data package or it's a remote package, that is included down here. So in the example over here, what we're doing is we are matching CAN ID 0, CAN ID 1, CAN ID 2. Actually, let's do it like this and put the high at CAN ID 3. And let's try to run that and see what happens. This should match all the packages we are sending, even though the CAN ID 3 is not matching our, but you see we only get one back. And that is because the ID remote bit is set, and if we look over here, that means that this bit is actually set as well. So when we shift 5, we shift the 11-bit value 5 to the left, we leave this at 0, and this is 0, and these 3 at 0. So if we want to match the remote packet, we have to have a 1 here. Otherwise, it will not match. So let's try to do that like this. So CAN ID 3, we shifted left 5 places, and then we OR that with the CAN filter ID remote, which, well, we could just see it here. Where was it? Here. We can see that I have set that to 00, 0001, 0000. So 1 bit in the with 4 zeros to the right. Let's see, that matches. So we have 3 here and we have 4. So we have 4 zeros here, we have that 1, and then we have whatever is over here, which is the actual ID shifted left. So let's try to run that. And we should see that we are now receiving 2 messages after 5 seconds. There, we received both of them. We have the type here, which is the one that is matching that 1 in the second place. That's why it's a 2. So that is about it. So this is all I wanted to talk about these filters. I think there's room for a future video where we are looking at the, you see, we are actually transmitting here. Where are we? Here. We are doing standard IDs. We have the option of extended IDs where you have 27-bit for the identifier, and we're probably going to try that out at some point, but at the moment let's stick with the 11. So that's pretty much all. This loopback is committed and will be committed, so I'll leave this in, so there's both options in the source code in the GitHub repository, so you can have a look at that. But let's finish this and let's look at, I created a new project already. Where is that? And I called it Dual CAN. It's here. So let's look at the CubeMX for the Dual CAN. probably need a faster machine actually to make these videos. Here we go. There we go. So all I've done here is, I mentioned already that I have attached one of these with wires shorted over between these two transceiver chips, which is wired up to the two CAN transceivers inside the board. So if you look down at connectivity, I have enabled CAN 1 as before, but I no longer have loopback mode enabled. I now have normal mode, and then I have CAN 2 activated, and again normal mode, no loopback. I have played around with different values, and I'm hitting around 1 million bit per second, which, I'm hitting exactly 1 million bit per second, which is the maximum that the transceiver can handle. So let's leave it at that, and let's look at the source code. I have already done this. So the idea is, as I mentioned a bit earlier, that I want to have CAN 1 running kind of a server that is not doing anything except waiting for requests, those remote requests, and then it will respond when it gets one of those requests. And I imagine two message IDs, one which is I call UPT, which will report the uptime, and one called R&D, which will report a random value. So whatever client is on that CAN bus or other node on that CAN bus can request the uptime of this device and can request a random value from this device, and it will get a response. So I also have, I won't be using these, I think, at the moment, so we can comment that out, but I'll use the update and the random, and I will have a CAN filter remote. So let's start by looking at our loop down here. We will have every 5 seconds, no, every 10 seconds starting 5 seconds in, I'll request, by sending a remote standard, I'll request the uptime. This will be transmitted on HCAN2, and the following 5 seconds later, also every second, it will request a random, and it will also send that on HCAN2. So it will ask for, it will send one of those remote requests out. Now let's look at the filter. In this case, I have created two different filters. I have created a filter for CAN 1, and I have created a filter for CAN 2. Now CAN 1, since that's a server, will only respond to the remote messages. Right, so it will look for the CAN UPT and the CAN R&D, and it will only match the remote one. So I'm using the ID list, two ID list filters here. So two different, we can add two more by using the CAN mask, filter mask, but not necessary right now. Now, an interesting thing is that the CAN receiver have different FIFOs, first in, first out buffer. It's got 2 or 3, I don't remember, doesn't matter. But in this case, we'll put it into the FIFO 0 buffer, matching this filter. We also set a filter for CAN 2. Now CAN 2 will only respond to the data messages. It will receive whenever it requests an uptime or a random value. It will wait for the response, and it will match those exactly the same. But we will notice that up here we have the slave start filter bank 13, and down here we set the filter bank to 13. CAN 2 is the slave, CAN 1 is the master. That's just how it is designed inside the STM32. It's got no other results. Each of them work pretty much exactly the same. We just need to know that we set the filters differently. We can also see in this case I put it into FIFO 1, so we'll have two different FIFOs, and one will receive for CAN 1 and the other one will receive for CAN 2. Now let's look at the callbacks. You will see that I have made a different one. There is a different one for FIFO 0 and FIFO 1. So let's look at the FIFO 0 first. That is the CAN 1. First of all, I have some check. If I actually get a message there, shouldn't happen. I should only get remote request, and we can see we have an uptime request and a random request. And if the uptime request, we prepare a response message, we create the uptime based on that, and we add a text message with that uptime. Down here, random, it's almost exactly the same, except I get a random number from the built-in hardware random number generator in the STM32, and that is about it. Now, those responses that are being transmitted here will be received down here. And that wasn't even simpler. I'll get the message no matter what. If the callback is happening, that means it matched the filter and the callback has been enabled. And then I'll see if the standard is an uptime, then I received an uptime and I print that. If it is a random, I receive the random value, and I have some error check. That should never happen. So that is pretty much all there is to it. We now have two CAN devices speaking to each other over a real CAN bus, and we are responding to remote messages. So let's look at the output for this. So they both woke up. That's a good start. And there we go. The first one. Let's hold this. Let's here. So CAN 2 is requesting uptime. That was down in the main loop. We have finished sending it. We have a pending message. We got a message on CAN 1. CAN 1 is transmitting an uptime message. That is complete, and then we have a message pending on CAN 2, and that received the uptime down here. Exactly the same with random. So there we have two different requests sent and two different response received back over the CAN bus. I think, okay, this video is not too long, but I think this is all I want to say. For me, the important thing to learn, and you really should try to understand that, I put it on the STM32 CAN page on STM32World, and you should really try to understand how these filters are designed and how they work. The image from the reference manual is very, very confusing, but once you understand how it works, the important thing is when it's 32-bit, we have these two after each other. When it is used in 16-bit mods, those two are actually separate. So this part is the one that was up here, 32. So in reality, we have two 32-bit registers. They can just be used in different ways, and this is how it is mapped. Look at that mapping. That is the important part. So up here, if you want to use extended IDs, it's really pretty much the same, except we have to fill in these datas, and that will require a little bit of bit juggling, I think, because they're not entirely. No, you can still shift them. You can just shift the extended address up, I guess. Yeah, well, I mean, it's important to understand these filters, and that was basically what I didn't fully understand that when I made the same video, so I felt I owed another video with this. As usual, this dual CAN will also be committed to GitHub, and you can I wanted to show the filter again. The filters are basically we could have had all this on the same FIFO buffer, so we could probably, since we're using 16-bit filters, I could have actually stuck with one filter and put the same filter on both. But no, I prefer to do it this way, and it's quite flexible. So that's about it. So I don't think I'm going to say any more now. As usual, have a wonderful rest of the days, and if you like this video, please like and subscribe below. If you don't like it, please let me know why, so I can improve these videos in the future. Bye bye for now.